Alright, so we're going to do the review for what is called practice test 3B. And so the first problem says, what is the probability a randomly household has at least 2 televisions? Well, we can do 1 minus 0.2 because the probability that you have at least 2 is 2 or bigger, which means 1 is the only one that doesn't work. Or if you prefer, you could add 0.25 plus 0.13 plus 0.30 plus 0.12, which also gives you the answer of 0.8. And so that's it for number 1. For problem number 2, we need to take all of the k's we have and set them equal to 1. So, turns out that 11k equals 1, which means k is equal to 1 over 11. Now, when we do this, to find the mean, we would do 2 times 1 over 11 plus 4 times 2 over 11, because 2 times 1 over 11 is 2 over 11, plus 6 times 3 over 11, plus 8 times 5 over 11. And you can use this using the table, or you can just plug these in. And when I multiply them together, I get 6.18 is the mean. And so the standard deviation would be the square root of 2 minus 6.18 squared times 1 over 11 plus 4 minus 6.18 squared times 2 over 11 ... And so when I put the information into L1 had 2, 4, 6, and 8, and L2 had 1 over 11, 2 over 11, 3 over 11, 5 over 11. We do the square root, the sum, another parenthesis, L1 minus 6.18 squared times L2, and whatever answer that gives me the standard deviation. And it basically comes out to be 1.99 for my standard deviation. For problem number 3, we're looking for the expected profit, which means we're looking for the mean. And so I make $20,000 3 out of 20, 3/20 of the time. I make 3,000 9/20 of the time. Break even means I don't make anything and I don't lose anything, which is 5 out of 20. And we lose 7,000, so I'll put plus negative 7,000, and that happens 5 out of 20. And so when we do this, that's going to get our expected profit, and we don't have to do anything else with this information. And in this situation, on average, we would make about $2,600. For problem number 4, it says you are going to roll a 20-sided die 10 times. What is the probability of getting 3 sevens in those 30 rolls? So let's just make it 30 rolls for both of them. And so we want 3 sevens. So we're going to do 30 NCR 3. The chances of getting a 7 are 1 out of 20, and I want 3 of those, and I want 1 minus 1 over 20, and I need 27 of those, because that means we got 3 successes and 27 failures. Remember that NCR is in the math menu under PRB. And when you plug it in, you should wind up with 0.127. And problem number 5. You select 20 cards from a standard deck of 52 cards. Let Y be the number of diamonds. What best describes this setting? Well, right now it's not binomial. And it's because of the independence. And it's also not geometric because we have set number of trials and there's no independence. However, if I wanted to change this to be a binomial, so let's just say that either I need to have millions of cards, or option number 2, maybe not millions but thousands. Option number 2 is to replace and shuffle each time. And then we have a binomial, and the binomial would be 20, and the P would equal 1/4 because there are 4 different types of cards. For problem number 6, in a large population, so we're not going to worry about independence, 40% have experienced math anxiety. If you take a random sample, what is the mean of the standard deviation? The mean will be 30 times 0.4 because this is n times p for the mean. And I will give you that formula on the test. And that turns out to be 12. And the standard deviation is the square root of n times p times 1 minus p. So that would be the square root of 30 times 0.4 times 1 minus 0.4, which is 2.68. Seven. What are the conditions for binomial and geometric? Well, the first 3 are the same for both, so we'll go through the first 3. So, number 1, we have independent trials. The second one is we have 2 results, success or failures. And 3, probability of success is the same for each trial. For the binomial, we have a set number of trials. For the geometric, we have trials until first success. And that's it for problem number 7. So the first 3 go for both, and then the fourth one is different for each one. Alright, since we're looking for the mean of the standard deviation, in L1 I'm going to put 1, 2, 3, and 4. And in L2 I'm going to put the probabilities of 0.5, 0.3, 0.1, and 0.1. And then I'm going to do the sum of L1 times L2, and that will give me the answer for part A. So go ahead and do that. And that turned out to be 1.8. And so, on average, the vending machine rents 1.8 DVDs per customer. For part B, I'm going to do the sum of L1. Don't forget the second parentheses because then you're going to be asking me what's wrong with the calculator. and I need to square root this whole thing. So that's going to give me the standard deviation. And that turns out to be 0.98 on average. The difference between the mean and DVDs rented is 0.98. And that's it for number 8. For number 9, we have a professional kicker who makes a goal 88% of the times. What is the probability that he fails to score a goal on his 4th penalty kick? Well, that means he had a success, a success, a success, and then a failure. So 0.88 to the third times 0.12 basically is 0.082. What is the probability that he scores 6 or fewer in his next 10 penalty kicks? So we have our binomial, and this is going to be the CDF. So 6 or fewer. So I'm going to do P equals 0.88, and then X is equal to 6 on my binomial CDF. 10 comma 0.88 comma 6, and since we're doing 6 or fewer, this should just give me the answer that I'm looking for. And that's 0.023. For letter C, how would I simulate this? Well, I would do from 0,1 to 88 is a make, and from 88.9 to 99 and 0,0 is a miss. So simulate and then do that for 9 two-digit numbers. Count the makes. So 0,7 is a make. I'm going to use M for make, and I'll use X for misses. 42 is a make. 85 is a make. 88 is a make. That's 4. 63 is a make. 96 is a miss. Alright, 96 was a miss. And then 02 is a make. And 38 is a make. And 89 is a miss. And so 7 makes is what the person did in this simulation. 1, 2, 3, 4, 5, 6, 7. Yep, 7 makes, 2 misses. I don't know why I put this down as an M. That should have been an X. Alright. Problem number 10. Okay, what are the chances that, so 33 were born outside the United States, you choose 5, so that means we're doing a binomial because we chose 5, and P is equal to 0.33, and in problem number 1, X is equal to 1, so we got 5, NCR 1, 0.33 to the first, 1 minus 0.33 to the fourth. So 5 NCR 1 times 0.33 to the first times 1 minus 0.33 to the fourth, and that gives us an answer of 0.332. For letter B, I'm going to do 1 minus because we're doing greater than or equal to 1 minus x is equal to 0. So 5 NCR 0.33 to the 0, 1 minus 0.33 to the 5th, and so we wind up with 1 minus 0.135. 1 minus 0.135 is 0.865. For letter C, the expected value is n times p, which is 5 times 0.33, which is 1.65. And for letter D, for the standard deviation, n times p times 1 minus p, all in the square root. So the square root of 5 times 0.33 times 1 minus 0.33 is 1.05. And that is it for the review. If you have any questions, let me know.